When is work said to be done by a force? Work is said to be done when a force moves an object through a distance in its own direction. What is energy? Energy is the ability or capacity to do work. What do you understand by a machine? A machine is a device that allows us to work with less effort. Machines make our work easier to do and give us comfort. What is the principle on which a machine works? Machines work on the principle that the work output of a machine is equal to the work put in. State two functions of a machine. 1. Changing the direction of applied force. Example, when a flag is hoisted with the help of a pulley. 2. Changing the speed of an object. Example, while riding a bicycle, force is applied on pedals which multiplies the speed. Name 6 simple machines. Give an example of each machine. 1. The lever. Example, a pair of piler. 2. The inclined plane. Example, staircase. 3. The wedge. Example, axe. 4. Screw. Example, a screw. 5. Wheel and axle. Example, handle of a bicycle. 6. The pulley. Example, pulley. Define the term work input and work output in relation to a machine. Work input is work done on a machine to get the desired output. Work output is the amount of desired work that is done by a machine. For an ideal machine, the work output is equal to the work input, that is, the efficiency is 1. Explain the term mechanical advantage of a machine. The mechanical advantage of a machine is the ratio of the load to the effort. In other words, mechanical advantage equals load upon effort. Define the term efficiency of a machine. The ratio of work done by the machine to the work done on the machine is known as the efficiency of the machine. Efficiency of a machine equals work output upon work input. What is an ideal machine? An ideal machine is the one in which no part of the work that is done on the machine is wasted. It is also called a perfect machine. Thus, for an ideal machine, the work output is equal to the work input and the efficiency of the machine is 1 equals 100%. Can a machine have an efficiency of 100%? Give a reason to support your answer. Efficiency of a machine is always less than 100%. The output energy is always less than the input energy, as some energy is lost to overcome friction. A machine is 72% efficient. What do you understand by this statement? A machine that is 75% efficient means that 75% of the work input is obtained as the useful output, and the remaining 25% has been lost in overcoming the friction. What is a lever? A lever is a simple rigid bar, which is free to move around a point, which is called fulcrum. Describe 3 orders of levers, giving an example of each. Draw neat diagrams showing the positions of fulcrum, load and effort in each kind of lever. Class 1 lever are the levers that have fulcrum in between the load and the effort. Class 2 lever are the levers that have load in between the fulcrum and the effort. Class 3 lever are the levers that have effort in between the fulcrum and the load. What do you mean by the mechanical advantage of a lever? The mechanical advantage of a lever is equal to the ratio of the effort arm to the load arm. This is also called the principle of a lever. Which class of lever has the mechanical advantage always more than one? Give an example. Class 2 levers always have more mechanical advantages than one. For example, a wheelbarrow, a nutcracker. Which class of lever has the mechanical advantage always less than 1? Give an example. Class 3 levers always have mechanical advantage less than 1. For example, sugar tongs, forceps. Give one example of Class 1 lever in each case where the mechanical advantage is more than 1, equal to 1, less than 1, more than 1, load arm of pliers equal to 1, seesaw less than 1, the load arm of a pair of scissors. Name the class to which the following levers belong. 1. A pair of scissors, Class 1. 2. A lemon squeezer, Class 2. 3. A nutcracker, Class 2. 4. A pair of sugar tongs, Class 3. 5. A beam balance, Class 1. 6. An oar rowing a boat, Class 1. 7. A wheelbarrow, Class 2. 8. A seesaw, Class 1. 9. A pair of pliers, Class 1. 10. A crowbar, Class 1. How can you increase the mechanical advantage of a lever? By increasing the effort arm or reducing the load arm, we can increase the mechanical advantage of a lever. How does the friction at the fulcrum affect the mechanical advantage of the lever? Friction at the fulcrum reduces the mechanical advantage. State 3 differences between the 3 classes of levers. Class 1. It has the fulcrum between the load and the effort. Effort arm can be shorter, longer or equal than the load arm. Load and effort, both are on the opposite side of the fulcrum. Class 2. It has the load between the fulcrum and the effort. Effort arm is bigger than the load arm. Load and effort are on the same side of the fulcrum. Class 3. It has the effort between the fulcrum and the load. The effort arm is always shorter than the load arm. The load and the effort are on the same side of the fulcrum. What is a pulley? Pulley is a flat and circular disc, with a groove on its edge, and a rope passing through the groove. It is capable of rotating around a fixed point, passing through its central axis, called an axle. What is the mechanical advantage of an ideal pulley? In an ideal pulley, the effort applied is equal to the load to be lifted. That is, effort equals load. Mechanical advantage equals 2, load upon effort, which is equal to 1. The mechanical advantage of an actual pulley is less than 1. Give a reason. What is the justification for using the pulley then? The mechanical advantage in an actual pulley is less than 1. Which means that the effort is more than the load. A pulley is used when the mechanical advantage is equal or less than 1. That is, a pulley allows us to apply the effort downwards, that is, in a convenient direction. To raise a load directly upwards is difficult. But, with the help of a pulley, the effort can be applied in the downward direction, to move the load upwards. One can hang on it, to make use of his own weight also, in order to apply the effort. Draw a neat and labeled diagram, showing a pulley being used to lift a load. How are load and effort related in an ideal situation? To raise a load, the load is attached to one end of the string and the effort is applied at the other end by pulling it in the downward direction. What is an inclined plane? What is its use? Give 2 examples where it is used. An inclined plane is a rigid sloping surface, over which heavy loads can be raised, or lowered to a certain height, or depth. The mechanical advantage of an inclined plane is the ratio of the length of the plank to the vertical height of the load raised. Its value is greater than 1. Therefore, an inclined plane acts as a force multiplier. Thus, it can be used to lift heavy loads. For example, if a heavy box needs to be loaded on a lorry, it is far easier to push it over an inclined plane than to lift it up. Steeper the inclined plane, greater will be the effort required to push up the load. Sloping ramps, flyovers, roads on hills, and staircases are a few examples of Inclined planes. What is a screw? Give 2 examples. A screw is a machine, and appears like an inclined plane, wound around a rod, with a pointed tip. For example, a jar lid, a drill. What is wheel and axle? Give 2 examples. The wheel and axle is a simple machine, having a wheel and an axle. The linear motion of the axle is obtained by rotating the wheel, so as to reduce friction. For example, steering wheel, screwdrivers, water taps. How does a wheel help in moving the axle? Wheel and axle arrangement consists of 2 cylinders of different diameters, joined together such that, if one is made to rotate, the other also rotates. The axle is a cylindrical rod, fixed to the center of a circular disc-like object, called the wheel. This machine acts as a speed multiplier device. In a riding bicycle, when we apply force on the wheel by the pedal, the fixed axle rotates with it, easily. This force, that turns the axle, produces a much larger movement of the wheel. What is a wedge? Give 2 examples. A wedge is a double inclined plane, such that the 2 sloping surfaces taper to form either a sharp edge or a pointed edge. For example, a knife, an axe, etc. In a few cases, the number of inclined planes used can be more than 2 as well. In such cases, the sloping surfaces generally taper to form either a very sharp or a pointed edge to split or pierce materials. For example, pins, nails, etc. The front end of a boat is shaped like a wedge, so that it can easily cut across the flowing water. The wedge works on the principle of an inclined plane. Name the machine to which the following belong. Beam balance, Class 1 lever. Lemon crusher, Class 2 lever. Sugar tongs, Class 3 lever. Ramp, an inclined plane. Doorknob, wheel and axle. Needle, wedge. What care would you take to increase the lifespan of a machine which you use? To increase the lifespan of a machine we can take the following measures. 1. Keep them in a clean environment, which is free from dust and moisture. 2. When not in use, machines should be kept covered to prevent the collection of dust on them. 3. Iron machines should be coated with paint to protect them from rust. 4. Machines should be regularly oiled with a good quality machine oil to reduce friction and the wear and tear.